In the meantime, a warm welcome on behalf of both of us. I'm Karl. I run a small company called WoodenDataCenter. We are dead serious about that. We build wooden data centers, and we brought a wooden rack. I don't know if you saw it, if you thought it was a cabinet to put up close. It's a no. We try to solve a specific problem, and we don't know anything about LCAs, and that's where Deborah comes in. Of course, it's really difficult, and she's the expert. But yeah, we set the scene because the Open Compute Foundation allows us with design files and specifications to actually do comparisons, right? And that's what we're here to talk about. Good. So this is the design files that we used for the comparison. You know, they look a little bit different. The rack that we have has, you know, liquid cooling on it and rear door cooling, but we initially tried to go from an, you know, primary school approach. So we found a materials pyramid, you know, multiplied the embedded carbon, and we actually did it. In a net zero industry, we built a net zero rack. We built a net zero rack. That was what we believed, you know, because of the limitation of what we know. But that is just the material impact, and that's obviously not including production life cycle and the end of use. And since we wanted to have a third party audited, we connected with Deborah in San Jose, really, and now we are here half a year later to share the results of that cooperation. So other things that we do and other things that we bring to the OCPs, 19-inch equipment, and we also have, we're also creating facilities that trying to change the narrative of data centers, you know, flexible load integration in microgrids, heat reuse, just trying to solve scope 1 to 4 with data centers. That's what we hear. But this is, you know, would be a building assessment in the future. We're happy to do that, you know, once somebody pays us some money to build our 180 megawatt data center.
So I was really pleased. I've been really pleased to work with Karl, because this is it's an exciting project, but it's also a little bit of a shift in thinking, which is really important when you think about the impact of data centers. And although, well, the results we're going to show you, you might think, ooh, that's not much, but it's the scale of little bits of carbon saving right across the industry are going to amalgamate to a lot of carbon saving. So this is a really important start. So when you're looking at life cycle, you look at all stages from materials extraction, turning it into something that's usable for your end application. And then there are lots of different end-of-life scenarios as well, whether you're going to take something out of service completely and either recycle it. You can, with certain materials, you can recycle in a closed loop, i.e. you can make them back into what they already were. Steel is a really good example of that. Other materials, they undergo change when you heat them for as part of the recycling process. For example, plastics. They're brilliant in their first life, but they lose inherent properties in their second life. So you have to find another application for that kind of material. And that's one of the things that we found with some of the materials that we're using in the WoodenDataCenter. So bear in mind that we're looking at an object, a product. We're looking at all the embodied impacts. Obviously, for what we're doing, there's no operational impact, no operational energy is included in the model, but we've got a whole array of different end-of-life scenarios.
And if I like to add, we only did, you know, the raw materials, you know, initially. And so if you look at the picture, you realize how difficult it is to approach this. You know.
Yeah. So our carbon assessment, we have an array of different versions. We've got 2 steel versions. One is using 100% virgin material, and then the second is a typical model. You know, most steel on the market includes a recycled fraction. 10% is typical. And then we have a plywood composite model for the WoodenDataCenter, obviously. A softwood, pine, very quick growing, but literally soft, so it gets damaged and dented. A harder wood model made from oak, which is more durable but takes longer to grow, so it's more of an investment. And then a hybrid, two hybrid versions. One has a ply base and pine uprights, ply base and top and pine uprights. The other has an oak base and, an oak uprights and pine ply top and base. And then we've considered the life of the product, and Karl reckoned, he's the expert on this rather than me, but he reckoned that it's not unfeasible to assume that a rack will last for 6 years in its first life. And then we have added in a second life, and that's a really important part of this model. There are lots of variables for the second life. One, we're looking at taking a product for 6 years and then recycling or downcycling it at end of life. We can send it to landfill, which you might think is bad practice, but actually happens a hell of a lot. And then we've got other options for extending life through reuse, which involves comparatively little reprocessing of the rack, and then remanufacture, which may involve things like sanding the surface, revarnishing, etc. So those are the end-of-life options. Now, when we look at a steel rack, here we've got some results. You can see the embodied carbon just for the steel. And we've got the two options. We've got the 100% virgin material and then the steel with the typical recycled content. The blue is the 100% virgin, the orange is the version with recycled content. Straight away, you can see, regardless of the life cycle, that including recycled steel is really advantageous. It has a lower impact. So looking along the chart, the first two bars are the product only with no end-of-life treatment. Second one is 2 lives. One product is sent to landfill at the end of its first life, and then you replace it with a completely new product. So that's bars 3 and 4. Bars 4 and 5, 1, 2, 3, 4, 5, I should put my glasses on, sorry. 2, 4. The next set, we have the life cycle, which, again, there are 2 lives. The first life, at the end of the first life, the steel is recycled, and we place it with a new rack. And then the second to last bars, we have product life extension through remanufacture. So there's some energy input, maybe require painting, etc., for remanufacture, maybe even a bit of metal bashing if it's been dented. And then the very last option is 1 life. Again, it's extended, so from 6 years to 12 years through reuse, 100% reuse, and minimum sort of human intervention there. So that's just to give you a bit of scope here. Then we come on to comparing the impact of steel and wood. And again, we've got exactly the same scenario. You've seen the WoodenDataCenter rack outside, I hope, which is composed of timber and steel. So we, again, have said that for the various wood options, which is pine, ply, oak, etc., but we have 2 versions of the steel components. One made from entirely new steel, 100% virgin, and the other includes recycled fraction. So again, we've got exactly the same kind of pattern, where use of the recycled steel with recycled content significantly reduces environmental impact. And again, similar pattern, but we have, you can see, so the highest 2 bars on the left, the steel, then we've got ply, an oak frame, a pine frame, and then the 2 hybrid versions at the end. Now we can see the pine frame is, has the lowest environmental impact, but it's the least durable of the materials. So is that beneficial? Probably not. It may, we say that we would like it to last for 6 years, possibly to go on to 12 if it's reused, but the probability is that the pine is soft and it will be damaged as you're taking servers and other equipment in and out of the rack. So that probably isn't the best choice. Something more durable would be, for example, the ply. Then the last sort of bit of analysis here. Again, the first set of bars, we're looking, that's the product only, no end-of-life treatment. But we can see here, again, the same sort of pattern in that the steel, the steel rack, we've got, sorry, I can't see them on here. Sorry, get the colours right this time. I followed the same colour pattern. 100% steel, then we have the steel rack with typical recycled content is the orange bar in every case. The third bar along is a hybrid, which is the oak and ply combination. And then the fourth, with 100% virgin steel components, the next one along is oak and ply combination with the steel with recycled content. So the same colours all the way through. Turquoise is the oak and ply hybrid with recycled content. And again, we have the same models for the end of life. The first set of bars said product only. The next one along 2 lives, we're sending product to landfill and replacing it with a brand new rack. The next one, again, 2 lives, we're recycling and downcycling at end of 6 years and replacing it with a new rack. Now, I mentioned downcycling. This is really, really important. If we're using pure timber, we may be able to compost it. Depends a little bit what it's coated with. Ideally, it should be a sort of organic varnish. The problem with ply, it's a brilliant material. It's really, really strong, really durable. You've got timber, thin timber sheets. Generally, they are, well, they're always placed sort of one vertically, one horizontally. They alternate. And they're glued together with either an epoxy or a polyester resin, okay? Fantastically strong. The resins does a damn good job, and then because you're alternating the grain, you are eliminating potential stress fractures in many respects. However, you can't recycle ply easily because of the glue. You can't compost it unless you're using a organic resin to laminate, keep the laminated layers together. So what you need to do rather than recycling is to downcycle, and you can chop it up into little chips and make chipboard or strand board, for example. So that's why I've said here we've got in those middle, the bars in the middle graph, or the middle bars in the graph, 2 lives. One is a mix of recycling. We're recycling the steel but downcycling the ply elements and then replacing that with the new rack. And then again, we've got our extended model through remanufacture and finally reuse. So we can see immediately that looking at the embodied carbon, the steel, pure 100% virgin steel has the highest impact. And then the oak/ply hybrid with steel with recycled content is definitely coming out as really favourable right across the board. So what does this mean for the market? Back to you then, Karl.
So thank you, Deborah. So apparently we didn't solve the magic, complexity and have net zero all of a sudden, but we are able to reduce the impact per rack significantly. We made a quick assumption about the market share, and so assuming about 1 million racks being deployed per year or sold in the US. So with a highest impact of 2 lives of 1 rack full, that has a saving of 342 tons per year. And that, I think, is really something to consider if we look at the overall industry. I'm not, we started here basically with 2 racks basis, so not every rack going to be in this direction, but even the impact on being sure that you use recycled steel and you focus on recycling steel as much as possible in the reduction scheme, we need to consider more variables and to go away, in the thousands of steel solutions.
And then, so we have our highest impact model and then the lowest impact model that we're saving less carbon, but that's not a bad thing really because, you know, we're using steel with recycled content. So it doesn't look as favourable, but actually it is better overall. And I think we're nearly there. So what are we going to do next? What we would like to do. So a carbon footprint is, at best, an indicative assessment of environmental impact. You're only looking at one really sort of critical factor. What we want to do is to do a really comprehensive life cycle assessment and to use much more sophisticated software, etc., to look at thousands of different inputs and outputs, so we have a much more accurate understanding of the whole life of these different products. So that's one thing, and when, I guess you've heard of cradle to cradle, we've our assessments have been sort of cradle to cradle, so we're thinking about closing that loop, starting from materials extraction all the way round through the use phase and then what happens at end of life and so forth. And we will do that for the LCA as well, the full LCA. And then this is just a list, if we are doing the full LCA, the whole array of different impacts that are considered in addition to climate. So we've got carbon, which is obviously contributes to climate change, but then we're looking at water, what happens to human beings. That's really important, particularly in things like mining, where not so much for steel and so forth, but a lot of the processes can result in health problems. And then abiotic resource depletion, fossil fuel resources, etc., etc. So a whole array of different impacts so that we can get a much more accurate understanding of the impact of the racks. The other thing, of course, is that we're not just looking at sort of the technosphere, if you like, we're also looking at a biosphere because we've got growing materials as well as the metals in there. And then the last call to action.
Yeah, feel free to reach out to understand. You know, we have so much really great initiatives in the sustainability project. Sustainability is weaved in all the other projects. We have to try and to look into going from cross, you know, racks and data centers, and to be able to think about all the, you know, dimensions that Deborah is opening up to bring that to all of those things. So happy to engage with you about that. Thanks.